We're just going to do a quick overview of experimental design and ethics. You may want to reference back to your book, but we are going to get more into that as we go on, and you'll be doing activities and problems where you'll be thinking about this and working with it more. So we just want to think about, like, is something ethical? Why do we need to do it? Is it really helpful? There's all sorts of different variables involved a lot of times. So we have in your book, it really goes into detail. This is just kind of streamlined here, so I'm just going to pull your book up to make sure you do read through that. Things like explanatory variable, that is your independent variable, what you're looking at. If you have two variables and you're looking at the relationship, and you have a response variable, that would be your dependent variable. We have treatments. We have experimental unit is the object or individual being measured. There's lurking variables or confounding things that could come up that aren't really part of it, but that cloud the study. We also want to make sure that we have random assignment that really helps with that. So read through this, and we'll go through some ideas on the homework as well, the class notes. So here we're just ironing out the definitions. Observational studies, when you're looking, there's no intervention. You're observing, you're measuring, you're just maybe going and finding data on the internet, kind of thing, that raw data from a study for our purposes. Like, you're just looking stuff up. There wasn't any kind of intervention that happened. Experiment is where there's a treatment or some kind of intervention that was measured during the course of the treatment. So in these scenarios here, for example, 1.19 is each describing observational or experiment. If it's an experiment, state the treatment. So we have A, the weights of 30 randomly selected people are measured. So think about that, if that is observational or experimental. And B, subjects are asked to do 20 jumping jacks and their heart rates are measured. That's fun if we're in an in-person class. I like doing that one. And if you have C, 20 coffee drinkers and 20 tea drinkers are given a concentration test. So go ahead and jot down your answers real quick. Just pause the video. So the answer to A is observational, so we're just measuring. B is experiment, they're doing the jumping jacks. And C is experiment, and they're taking the test. Confounding occurs when there are two potential variables that could have caused the outcome, and it's not possible to determine which actually caused the result. When one variable causes change in another, we call that first variable the explanatory variable, and the effective variable is called the response variable. And you may have heard of these as independent and dependent variables. Example 1.20, a drug company claims people lost an average of 8 pounds while using a weight loss pill. What could be some other variables that cause the weight loss? Is this confounding? Why or why not? So take a minute to think about that and jot some things down. There's all sorts of things that people could say. It'd be fun in a group if we could hash it out, but online, just go ahead and jot yours down, and then I'll put some thoughts of mine. So some things I was thinking about is like diet, exercise that could make a difference. Maybe they're just taking the pill and they think that's good, so they're like kind of more conscious, they're not just mindlessly doing something and eating more. It's confounding because we can't know for sure if the pill did the actual weight loss, cause the weight loss or not. So there are ways to kind of work within those constraints that studies are done. There's lots of things out there now. But in general, it's pretty hard to tell. So here's my answer. Other factors: diet, exercise. Confounding because we can't conclude if it's the pill or other factors. That's the main thing. And we'll look at ways to combat that. So if we have a study going on, we're going to have 2 or more groups. There's a control group and a treatment group. The treatment gets the treatment and the control group does not, but they might get like a placebo. Usually that's a really good idea. And if there's a placebo, it's either might be double blind, like the subject, the experimental unit of the person that's being studied is not aware which one they have, the real one or the placebo. And in double blind, also the researcher doesn't know either, because they could just kind of influence without even realizing it. So it's good to keep it all under wraps to have a good study. So let's see, if we can determine a reasonable placebo for each scenario. So this is example 1.21. A study for a new medicine that is dispensed in a pill form. That's A. B, a study on the effect of alcohol and memory. And you can write down your ideas here. And then I'll put mine. But just kind of think like, common sense wise, what do you think would work? And then you might think, well, there's certain things that definitely wouldn't work, but what might work in this case? The last one is a study of a frozen meal diet plan. And some might be harder than others. Okay, so for A, we could think about like a sugar pill. B, we could do a non-alcoholic beverage that's looking or tasting similar. Might be easy to tell though. And C would be a frozen meal that's not a diet one. Example 1.22, researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into 2 groups. One group will take aspirin and the other group will take a placebo. Each takes 1 pill each day for 3 years. But he does not know whether he is taking aspirin or the placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. Identify the following values for this study. What's the population? So kind of think back to the beginning of the chapter. The sample, experimental units, explanatory variable, response variable, and treatments. Okay, so give you a minute to process all that, and you may need to think back, but we're looking for kind of the broad concepts and labeling those key terms. So you can take a minute to look that up, just pause the video. Okay, so hopefully you've had a moment to jot those down. If not, do it now. So the population, we have to look up here that it's men between the ages of 50 and 84. And of course, we're not going to get all of them. So we are I'm just doing a sample. So of 400. Okay. And we're told that here 400 are chosen. So that's the sample. Experimental units are men in the study. So even though it sounds like it's a thing, it could be a person too. Explanatory variable is the pills the men are taking. Response variable is the number of heart attacks. So what the intervention is, that's your explanatory or your independent variable, and then the outcome, what's dependent upon that, would be the number of heart attacks. Now, there is questions sometimes about, is that ethical to do something like that, not give them the good pill? But really, we will go into a little bit of that. That's really complex and complicated. So just thinking about that was kind of involved. But start kind of thinking about that. What do you think? It'd be a good topic for discussion. Treatments are the pills. Would be they either get the aspirin or the placebo. Okay, I think this is almost the last one. In a blind study, the participant is not informed whether he or she is receiving the treatment or the placebo, and I talked about this a moment ago. And double blind is when the participants don't know and also the researcher don't know. So in this scenario, example 1.23, to test a new lie detector, 2 groups of subjects are given a new test. One group is asked to answer all the questions truthfully, and the second group is asked to lie for one set of questions. The person administering the lie detector test does not know what group each subject is in. Does this experiment have a control group? Is it blind, double blind, or neither? Okay, so given the definition up here, we have 2 groups. Okay, one is asked to answer truthfully, second is asked to lie for one set of questions. This makes me think of a show I've watched recently, Poker Face. It's really good. She can tell when someone's lying. The person administering the lie detector test does not know what group each subject is in. What is a control group, if there is one? Is it blind, double blind, or neither? And I think it's a little bit tricky, so take a minute to think about that and jot down your answers, and then we'll see how we match up. Okay, so the control group, yes, there is one. It's the group that's telling the truth, to see if it really works, And then the blind, it's a blind experiment, not double blind, because the groups know, but the administrator doesn't know. So we can't say it's a double blind, because obviously the subjects have to know what's going on. And here's a video link that you could use out of your workbook if you want to see more about that. And then here's some information about, ethics and how that can come into play, and how we have risks that have to be minimized. They have to have informed consent and all sorts of stuff going on. So you can read through that, but we'll touch on that more a little bit later. Maybe have a discussion point about that in one of your modules would be a good idea. And that's it for chapter 1. Have a great day, and you can move on to your electronic homework.